What's up, 8th grade? Mr. Agnos here. Today we're going to start topic 5, and in this unit we're going to start looking at what are called proportional relationships. And a proportional relationship is where you have a constant amount of one thing in relation to another. So an example of that would be like the number of points you get for scoring a touchdown. So let's forget about the extra point here for a second. But if I score 1 touchdown, I get 6 points. 2 touchdowns, 12 points. 3 touchdowns, 18 points. So there's this constant relationship of 6 points for every touchdown I score. 0 touchdowns, 0 points. So that's an example of a proportional relationship. So let's go ahead and take a look at a proportional relationship. We're going to look at a graph. This unit's going to involve graphing, so we're going to have to refresh our memory on that. But I'm expecting lots of questions because there's a lot. I'm going to throw a lot of new stuff at you, and I don't have enough time in the video to explain everything. So whatever you don't understand, whatever questions you have, make sure you ask those in class. Okay, so it says your school is selling raffle tickets as a fundraiser. Excuse me. The raffle tickets are sold in groups of 4 for $3. They want us to draw a graph to model the situation where the horizontal axis is the number of raffle tickets purchased and the vertical axis is the total cost. And then ultimately the question that we're trying to answer here is you have 21 bucks, how many raffle tickets can you buy? Now I'm sure a lot of you can just in your head sort of intuitively figure this out, but we want to look at all the pieces of the puzzle here. So what I'm going to do is I'm going to go ahead and click on the answer and walk you through a bunch of what I'm talking about here. All right, so the first piece of information that we have is that each group we can only buy tickets in groups of 4 for $3. Okay? We can only buy tickets in groups of 4 for $3. So let's think about that for a second. I'm going to make a little table here. Okay, this is tickets, and this is money, and I can only buy them in groups of 3. So I could buy 0 tickets, and that would cost me $0. I could buy 4 tickets, that would cost me $3. I could buy 8 tickets, that would cost me 6. I could buy 12, that would cost me 9, and so on. Okay, so that's what we're looking at here. They want us to draw a graph to model this situation. Well, remember a graph, we have an x-axis, right? That's our horizontal axis right here. And notice that our x-axis is measuring the number of raffle tickets. And a graph also has a y-axis, and y-axis is the vertical axis, and notice that our y-axis is measuring money, right? The total cost. And then I have all these different little dots on the graph. Now your first question might be, well, why do I have dots here instead of a straight line? All right, why don't I just have a nice straight line? Ooh, that's, yeah. Well, I'm trying to make it straight. Why don't I have a nice straight line like this? Well, remember that we can only buy them in groups of 4. So for example, I can't buy 3 tickets or 2 tickets. I can only buy them in groups of 4. So if I look at the number of tickets down here, 4, 8, 12, it only gives me the numbers that I can actually buy. I can't buy 22, for example. So this might be the number 22. There's no dot there, right? If I go up, there's no dot there because it's not an option for me to buy that amount, right? So that's why we only see dots, because those are the only places where we can actually buy tickets. Okay. So this is what our graph is going to look like. I can buy 4 tickets, 8 tickets, 12 tickets. And let me show you how we use this graph. Let's look at this point right here. This corresponds to the coordinate pair 12, 9. Since the x-axis is measuring the number of tickets I could buy, well, in this case, 12 was my number of tickets, so that's my x, and 9 was the total cost. So the way that you read a graph is, in this case, I'll go over to the number of tickets, 12. I'm going to go up until I hit a dot. I hit a dot, and then I go over, and notice that I get the exact same 9 that I had over here. So if I asked you, hey, if I want to buy 36 tickets, what's that going to cost me? Well, you can use the graph to figure that out. You go over to 36. There it is. I go up until I hit the corresponding dot, and then I go over, and it will tell me the cost for 36 tickets. So 36 tickets are going to cost me $27. All right, so the question they want us to answer is, you have $21. How many raffle tickets can you buy? So this one's actually a little bit different than the example I just used, because here they give me the dollar amount, right? $21. So in this situation, I need to find $21 on my y-axis. There it is. And I'm just going to move in the opposite direction. I'm going to say, okay, I'm going to go horizontally until I hit a dot. Then I'm going to move down, and I can buy 28 tickets for $21. That would be the point 28, 21. All right, I go over 28 units, I go up 21 units, and there I am at the number of tickets I can buy. Now, the graph of a proportional relationship has, of all proportional relationships, have several things in common. Number one is they're all going to pass through the origin. They're all going to pass through the point 0, 0. That is right here. That's because, in this case, for example, if I buy 0 tickets, it's going to cost me $0. If I score 0 touchdowns, I'm going to have 0 points. If I make 0 3-pointers, I'm going to have 0 points, right? If I have 0 $100 bills, I have no money, right? I have $0. So every proportional relationship is going to pass through the origin. The second thing that all proportional relationships have in common is they're all going to be in a perfectly straight line. Okay? You're not going to get any curves or wiggles. So if you get a question where they ask you, hey, does this represent a proportional relationship? And they give you some graphs, you're looking for two things. Does it pass through the origin? And is it a straight line? If it meets those requirements, then you know it has to be a proportional relationship. Let's try and look at one more problem here in the time remaining. Okay, so this problem says a drill makes a well by tunneling down into the ground. All right, so I want you to imagine that we have the ground over here. All right, this is obviously ground. And we have a drill. Okay, here's my drill. All right, and the drill starts drilling. Nope, not sure what happened there. The drill starts drilling, and so we're going to drill down this direction. And as we drill down, 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 right, we're going to start making a hole, and the hole will get deeper and deeper and deeper, right? So we're drilling a hole, all right? And it says a certain drill can tunnel down 10 meters. So first off, down, right? So you should be thinking negative numbers here. It can drill down 10 meters every 8 hours. Draw a graph to model the situation where the horizontal axis is time and the vertical axis is the position of the drill. And then it says, is the position of the drill head relative to the surface proportional to time? All right, let's take a look at their graph here. Well, actually, they do a couple things here for us. They made a table of values. So similar to what I did in the first problem, here, based on this information that they give us, that we go 10 meters every 8 hours, notice how we're moving by 8 every time. Right? So here it's like, okay, we're only measuring in chunks of 8. So on the left-hand side of my table here, we're always increasing by 8. And every time 8 hours passes, notice how the drill gets 10 meters further into the ground. Right? And the reason that my number is negative is because we're going below the ground, right? So after 8 hours, we have drilled 10 meters underground. After 16 hours, 20 meters underground. After 24 hours, 30 meters underground. and so on. And we could even add a value to this table here. We could say if I drilled for 0 hours, I'm going to put a 0 right here. Well, where would the position of my drill be? Well, I'd be 0 meters underground, right? I haven't drilled anywhere. All right, let's look at the graph of this relationship. All right, one thing I want you to notice about this graph is that it goes down from left to right. So in other words, if I start here, we always read graphs from left to right. So if I start here, notice that we're going down. And literally, it's almost like we are actually drilling. And after 8 hours, right, after 8 hours, we've gone down 10 meters. So this graph is telling us the exact same information that our table was. After 24 hours, I've gone down 30 meters. So the question is, does the graph show a proportional relationship? Well, remember what I told you previously. You only need two things to know if it's proportional. Does it pass through the origin? Yes, it does. Okay, there's the point 0, 0. If I drill for 0 hours, I'm going to be 0 meters underground. So that's the first requirement. So I'm going to put a little check mark next to that. That's the first requirement. And then does it form a straight line? Yes, it does. It forms a perfectly straight line. So I know that this must represent a proportional relationship, right? It meets these two requirements. So yes, it is a proportional relationship. And if you're curious where this number negative 1.25 comes from, well, if I decrease by 10 meters every 8 hours. Remember, fractions are a division problem. So if you go ahead and divide negative 10 by 8, right? Negative 10 meters per 8 hours, this is going to equal negative 1.25. So that's where this number is coming from, and we call that the constant of proportionality. This is the amount that the drill is going down every 1 hour. So I can say negative 1.25 every 1 hour. Now our problem had us going in units of 8, so I'm not too concerned with this number right now. We'll talk more about this in this unit. But this is called the constant of proportionality. In the touchdown example, 6 would be the constant of proportionality, right? For every 1 touchdown, I get 6 points. 2, I get 12 points. 3, I get 18 points, and so on. All right, I'm already 13 minutes in here, and I feel like maybe I've rambled a little bit. I've thrown a lot of stuff at you. I think the best way to get started is just to jump in and start looking at some of these problems. You guys are familiar with proportional relationships. You've used them before in your lives. Maybe you haven't talked about them in the way with the mathematical terms, but you certainly know what touchdowns are and three-pointers are and what $100 bills are. And if you have $800 bills, well, that's the constant of proportionality in that case would be 100, right? 8 times 100 means you have $800. If you had $0 bills, you'd have no money. So let's go ahead. Let's take a look at some of the problems. Please, please, please ask questions. I'm going to do a bunch of these problems in class so we can talk about the constant of proportionality. We can talk about how to use the graphs. So you're not supposed to know this stuff perfectly after this video. This video is just a tiny introduction. It's like, here's a little sampler. Now let's go explore the main feast together. Okay. Hopefully this video was helpful just to introduce this idea of proportional relationships and refresh a little bit on graphs. Make sure to ask lots of questions in class, and I'll talk to you guys soon.